Hi, you're listening to Stephan Livera podcast, a show about Bitcoin. Today for episode 292, my guest is Andrew Chow. He is a Bitcoin Core contributor. He is well known as the creator of the PSBT standard and hardware wallet integration, as well as a range of other things, mostly working in relation to Bitcoin Core's wallet. And so today we're talking about the creation of a series of BIPs, Bitcoin improvement proposals, in relation to Output Script Descriptors. And so this episode is going to be a little bit challenging for the new listeners out there, but I do my best to explain this for people and talk about some of the implications of this. And we break down and explore various concepts around seeds, BIP39 versus other types of seeds, derivation paths, how output script descriptors improve things, as well as new functionality, dealing with backups and recovery, Lightning, Miniscript, and advanced scripting. This show is brought to you by Swan Bitcoin. Swan is the best way to accumulate Bitcoin with automatic recurring buys and instant buys. Swan make it easy to sign up and get started with an auto stacking plan. Those of you in the US, you can set up an ACH plan that includes automatically pulling from your bank account, buying Bitcoin, and withdrawing to your self-custody. The withdrawals are free with Swan. Those of you internationally, you can wire in funds. Swan take a specific focus on education and content because the more you know, the more you buy. So Swan are a great place to send your pre-coiner and new coiner friends. Also, if you're a high net worth individual or you're with a business or corporate and you want to stack as part of that entity, Swan Private are there to help on that aspect. Swan Private provide direct access to a dedicated Bitcoin expert who is available for one-on-one calls. You get additional guidance, self-custody guidance, wire support with no limit on purchases, and retirement account guidance. So to sign up, go to swanbitcoin.com/Livera. Lend at HODL HODL is a peer-to-peer Bitcoin-backed lending platform, so you can lend out stable coins or borrow against your Bitcoin globally and anonymously. There's no KYC. So Lend at HODL HODL allows you to earn extra income on your stablecoins by lending them out. On the other hand, if you need liquidity and you've got Bitcoin you don't want to sell, well, you can borrow against your Bitcoin. And the best part is you still hold one key in the 2 of 3 multi-signature controlling your Bitcoin. HODL HODL does not hold your funds and there's no rehypothecation. So this is a peer-to-peer lending and borrowing platform directly between users. So you go on the platform, you set your terms and put up offers depending on how long you want to borrow or lend and the interest rate. Go to lend.hodlhodl.com. Do you want to get involved with Bitcoin mining? Compass is an online marketplace making it easier for everyone to mine Bitcoin and enhance the Bitcoin network's security. So with Compass, you can purchase an ASIC using the deals that they have negotiated with the mining manufacturers, as well as tapping into the economies of scale that Compass can provide on both mining equipment and also hosting at a facility. Also, Compass have a special deal on now. It's called the VIP bundle. As part of this bundle, you get 12 machines. It's $32,400 upfront, plus $1,800 per month, plus the hosting cost. But this is a big discount if you were purchasing these 12 machines individually. And this is 12 new Antminer S19J 90 terahash units. So go and check out the website. It's at compassmining.io. Andrew, welcome back to the show.
Hey, thanks for having me.
So Andrew, you've been working on a bunch of things, one of which was the output descriptors idea. There's been a little bit of progress on that. So maybe just tell us a little bit about what you're working on lately.
I've been working a lot on the Bitcoin Core wallet as usual. We've been preparing to support Taproot with the next major release of the Bitcoin Core software. So for the next release, 22.0, we're going to be having the ability to spend Taproot outputs from the core wallet. And so this is in preparation for Taproot's activation in November. So I've been working on a bunch of stuff related to getting that to work, like output descriptors for Taproot and PSBT fields for Taproot.
Awesome. And actually, I think I saw on Twitter there was some people commenting. I think it was Instagibbs, Greg Sanders, and maybe one or two others who were saying, I think they had found out that there were actually some Taproot outputs sitting there that someone could spend. I think someone had spent like a small amount just to play around with.
Yeah. So I'm not sure I saw that, but I do know several months ago there was a test to see what wallets actually support sending to Bech32 addresses for SegWit v1 and above. So Taproot uses SegWit version 1. And it was at that time we wanted to see if all these software were actually compliant with BIP 173, which says that if you get an address for a version number that you don't know about, you should still make that output, because it's not really your, as the sender, it's not your place to worry about whether the receiver can spend it. So there was a bunch of tests done where someone made a best32 address for SegWit v1, uh, went to as many wallet software, custodial services, whatever, anyone who could send Bitcoin somewhere, and see if they could make a SegWit v1 output. Some of them did correctly, and those are probably the outputs that you can see on the network today. Some of them did incorrectly, so there are a few burned coins, and some of them just didn't work at all.
Well, pour one out for the sats we lost on the way, hey?
Yeah.
Well, yeah. So let's talk a little bit about Bitcoin wallets, and hopefully this will be educational for listeners out there who are just thinking, oh, I just have a certain number of coins in my wallet, or I've got certain, it just kind of manages it all in the background. Do you want to just outline a little bit what's actually going on there in the background, and where is the output descriptors fitting into that?
All right. So in a wallet, obviously you have keys, but Bitcoin doesn't actually operate on keys themselves. We use this thing called Bitcoin script, and when you make a Bitcoin transaction, the outputs that you're sending Bitcoin to, you put a script there. And the way to know what script to put is through an address. An address is a human shorthand for saying use this script in a transaction's output. And so your wallet will generate keys. From those keys, it generates scripts. And from those scripts, it makes addresses. And when you want an address, you click get an address. It gives you an address that it made from a script that was made from a key. This is usually how wallets work, where everything is based on that key. With descriptor wallets and output descriptors, we're slightly changing that, where actually the base step is the script, and the script says, I have these keys. So instead of going from key to script to address, we just go script to address, and then the script has some internal thing like we have a key.
Gotcha. Yeah. So, and there are different situations for listeners out there because, obviously not every listener is just using the Bitcoin Core wallet. Probably a lot of users are using some form of hardware wallet. They might be using that with Spectre or Sparrow or Electrum. And there's maybe, it's a slightly, I mean, it is like what you're saying. Yeah, it is still that, but it's like a different way of kind of happening. Maybe it'd be good to just talk a little bit about the common standards, like for example, BIP39. Could you just outline a little bit about how those wallets are working from like let's say I've just created a wallet and I've got my 12-word seed or my 24-word seed BIP39. How does that relate to what you were just saying?
Yeah, so that's all based. That's all related to the keys part of the wallet. So BIP39 is a BIP that specifies how to encode a bunch of random bytes as 12 words, 18 words, 24 words as the thing as those words that you memorize. And from those words, we use another BIP32, to derive all the keys in your wallet. So you can have a single source of randomness, and from there be able to derive all the keys that you're going to use. And so if you just back up that single source of randomness as a mnemonic, then in the future you will be able to restore your wallet by just using that single mnemonic phrase, because you can regenerate all the keys that you previously used. So BIP32 is a method for doing that. And BIP32 has these things called derivation paths. So you can say derive the first key, and then from the first key derive another key, and from that key derive another key, and that's how you get like M44 H0H, like those derivation paths that you might see. And then the next level is we have BIPs like BIP44, BIP49, 84, and now 86, which describe those derivation paths for scripts that we want to use. So if your wallet is, say, BIP44 compliant, then if it supports BIP39, 32, and 44, then you have your 12-word mnemonic. From there, we use BIP32 to generate the keys, and we generate the keys specifically that BIP44 says to generate. And then from there, those keys that we generate, we turn into a specific type of address, which is the pay to public key hash address. And those are the addresses that begin with a
Yeah.
1.
Okay, so just for listeners who might be struggling to follow along, think of it like this. Your wallet's managing all of this in the background, but we're just trying to talk out the dynamic or talk out what's going on there. So let's say you spin up a wallet, you initialize a wallet. That could be a hardware wallet or it could be a phone wallet, something like a Blue wallet or one of these other ones. It will give you that 12 or 24 words. That words represents your secret. And then from that secret, using these standards we were just talking about, so that's BIP32, BIP39, that particular seed type, and then using these particular derivation paths, and these are specified in the other BIPs that you were mentioning, so 44, 49, and 84, and they will correspond to the different address types. So like the address types that start with a 1, addresses that start with a 3, and nowadays the default, which is BC1, which most wallets are using that. And so we can think of it like that initial seed that you've got, that's really the thing you have to be careful with, and then everything else will get generated out of that. But I think to the point of output descriptors and all this stuff is that we're moving into a world where perhaps things are getting more complex than the simple setup that we had in the past. So could you outline a little bit around that complexity and why there's a need now for this more generalized approach as opposed to the very specific sort of BIP 44, 49, and 84?
Yeah. So as Bitcoin grows, we're learning that there's a lot of other useful things that you can do with it, especially with Bitcoin script. So if you want to do, cool things with scripts like contracts or even Lightning or other things that aren't just a key that signs, um, it's hard to represent those in a wallet. And output descriptors are kind of moving towards that. But descriptors also actually solve a different problem. So so everyone who listened to my explanation might have gotten confused by all the different BIP numbers. And if you wanted to take your wallet to somewhere else, uh, and make sure that you could still see all of your addresses, you would have to figure out, the software that you use originally, what BIPs does it support, go to a different wallet and see, does it support the same BIPs, and will it by default use those certain BIPs. So uh, as an example, I believe if you try to import something into Electrum, it will ask you, do you want SegWit or do you want legacy? uh, so that's P2W or P2 And if your previous wallet supported both, so you could have a wallet that had both non-SegWit and SegWit addresses, in Electrum you only get to use one of those kinds of addresses. And this gets really confusing to users. It can be frustrating when you're restoring a backup, if just between software versions, or if you want to try out a different software that has different features. And descriptors actually solves this problem for us. It'll still be multiple BIPs, but it won't be like, three things chained together. It won't be you have BIP 39, then 32, and then 44 or whatever. It'll be just like BIP. I don't know what number Luke is going to give it, but some BIP number, maybe a different one saying like, we support this specific function. Uh, and descriptors, the way that we're able to compress all of these different things into one is that the descriptor contains the the key, the seed rather, that you derive everything from, and then the derivation path explicitly. So um, instead of saying, I'm using BIP 39 with BIP 44, is just, here's a key plus its derivation path. I don't need to care about that the derivation path is BIP 44. It could be whatever I want. Any wallet that supports a descriptor will know how to derive those keys because the derivation path is attached to your backup. And then the last part is the descriptor itself will say what kind of script to create. So um, it'll say like, make a P2PKH script or make a P2WPKH script or whatever, instead of trying to infer that based on, we're using BIP 44 or we're using BIP 84. It just says it right there on the descriptor. So your single backup string contains everything that the new wallet needs to know to recreate your wallet. And that's really what that's like one of the major things that descriptors solves, and was one of the original motivations for creating them.
Gotcha. Yeah. So just to paraphrase that, it's like saying it's like giving your wallet the map to know where to find all the coins, if you will, and knowing what type of scripts to look at, whether that's, as you're saying, P to PKH, so pay to public key hash, or the other one was it witness public key hash, or the script hash types and the different ones. So basically, it's sort of pointing your wallet where to look and how, on what pathways to go down, if you will, in terms of generating a new address when you want to generate a new receive address, and the keys associated for that. So it's kind of all helping the wallets manage those things together. I'm also curious, Andrew, if you could maybe give some context for us on the different seed types. So I know, years ago, BIP39, I think it was one of those ones where it's like it seems to me like some of the core developers weren't as hot on BIP39, but it seems like that was the way the industry went, because a lot of the hardware wallets use BIP39, a lot of the phone wallets use BIP39, although obviously Bitcoin Core does not use that at a protocol level and at like the wallet in Bitcoin Core. Could you just outline some of the thoughts around that and some of the different seed and standards and things?
Yeah. So, really, the only standard that we have as a BIP for seeds and mnemonics is BIP39. So BIP39 is the de facto standard by there being the only one. Electrum has their own seed format, which so they moved. They also didn't quite like BIP39, and they decided to go do their own thing. So they have a incompatible seed format that is similar to BIP39. It's still, I think it's still 12 words. It's words that you can memorize. Um, but really, it's really BIP39 and Electrum, and in both of these, the seed only really pertains to the keys. So BIP39 is only like from this seed we can make keys, and Electrum's is pretty similar to that. Is from this seed we can make keys. Although Electrum also says Electrum has a version number that is kind of a hint to the software, say, use these keys to make a P2 WPKH address, or something like that. Um, so these are the two main seed formats. Bitcoin Core has chosen to not implement either of them. Uh, this is partially due to some philosophical objections to BIP39 itself, and partially due to the fact that it's hard to do and no one feels like doing it.
Yeah, and I think it's one of those things where things don't necessarily all have to be done at a protocol level. I think it's fair to say that if people want things, then they can potentially be done at the application level, and that's I guess it's all part of the market and the choices made by the individuals and the businesses out there who are building in the Bitcoin space. So yeah, so I guess that's a crucial difference for listeners to understand. Like, if you are just using the Bitcoin Core wallet, it's not going to give you 12 or 24 words, and it's a different type of backup. You're going to have the wallet.dat file, whereas if you're using the typical hardware wallets and all that, you're going to generally have the 12 or 24 words as your backup.
Yeah, and the a lot of this, I would say, actually does come down to the fact that the way that Bitcoin Core was, the at least the wallet was organized from the very beginning, was not very conducive to having a seed. I mean, it was difficult just getting BIP32 into Core itself.
Yeah.
So getting more complicated things like uh, BIP39 was a little a lot harder to do, and a lot of work has been put into a new architecture for using output script descriptors as the the way that the wallet works. So we have descriptor wallets, which basically cut out all of the old stuff and just added a complete new implementation that uses descriptors.
Yep. And I'll note as well, there is an interesting example with Moon Wallet. I'm not sure how familiar you are with them, Andrew, but Moon Wallet is their backup is actually using more of an output script descriptor approach, as I recall from my episode with Dario from the team at Moon, where their backup is not like the typical 12 or 24 words. It actually is like the whole descriptor style of backup, where you're writing these things down, and it combines with the different pieces to create that script descriptor approach, whereas most other wallets are just doing the typical BIP39 or Electrum seed. Or actually, I think there's also the aezeed, which is like the Lightning Labs LND style
Oh yeah, there's
one
that.
as well. Um,
I forgot LND had also made their own seed format.
Right, yeah, yeah. And I think the typical reason is that they wanted, I think it was a version control and also a birthday thing to say this seed was created on this date. So therefore, when the wallet is going back to rescan the chain to sort of figure out how much money you have or what transactions you've done, it knows at what point to start the search as opposed to searching all the way back to January 2009 when Bitcoin's blockchain started.
Yeah, that's actually one of the complaints with BIP39, and why we see that there's Electrum C, there's aezeed. It's like BIP39 is literally just randomness with a checksum. It doesn't have a version number. It doesn't have a birth date. It doesn't have any other like security on it. It's just here is randomness, and we stick a checksum on it just in case you type something wrong. Uh, so so I believe Electrum added version number, and I think they might have also had a birth date. And I guess AZ has version number, birth date, and I seem to remember they also have a way to encrypt the seed as well. So it's not just the randomness we use in your wallet, but the randomness encrypted. So if someone takes it, they don't necessarily take your whole wallet.
Yeah, interesting stuff. Hey, so I guess at the end of the day, it's going to change the way people do backups longer term. But potentially for now, in a typical multi-signature context, you might have say 3 hardware wallets or 5 hardware wallets or however many you're doing. And for each of those, that user might have a 12-word or a 24-word seed. And for each of those, they might want to do a metal backup seed product, right? To have like everything, backed up in metal. But I guess that also does introduce another complexity now for the output script descriptor context, because how do you think people would be writing that out into metal, or what? Do you have any thoughts around that, or you kind of you don't really have a position on that?
Well, descriptors was specifically designed so that it is human readable. So it's not binary, and you these characters they exist on a keyboard. So I'm sure you could get metal stamps or whatever to stamp it into metal if you wanted to. Um, descriptors can be quite lengthy and verbose. So it might not be something you want to put into metal, but if you did, it definitely contains all of the information that you need to restore the wallet completely. So you have all your derivation paths, and you know what kind of addresses to make. And descriptors also have a error correcting checksum. So like Besh32, if you have a typo somewhere, it will be able to find it. It'll be able to tell you where it is, and in many cases, it'll be able to tell you what it should be. So even if you mistype it, you're not completely out of luck. Um, the checksum should be able to tell you where you've made your mistake, and even tell you how to fix it. But other than that, like descriptors as a backup isn't quite as neat as memorizing 24 words or 12 words. Uh, and it would be it definitely takes up more space because it's going to be more characters than mnemonic.
Gotcha. Yeah. And so I guess from what I have seen so far in the space, for example, Spectre Desktop is another popular wallet. Uh, and that wallet does have a backup file that you can do. And it's also got a QR code. So that QR code represents the output script descriptors of that multi-signature wallet or a single signature, if that's what you're using. And so that's one potential way things go, is that maybe these would be stored on, say, a USB key, and that USB key would maybe be left with the metal seed backup as like a way for people to recover. Obviously, there is a privacy concern with that, but it's again that trade-off of how much redundancy do you want, the ability to always recover it versus the privacy if someone stumbles across this backup and is able to then see, oh, I see how many coins Stephan or Andrew has, and I know where they are, that kind of thing.
Yeah. Um, Even with descriptors as a backup, there have been some ideas around encoding descriptors in a different way. So there's definitely a possibility for yet another mnemonic method, but one that's generic and can just encode any chunk of data. So there's been some thoughts around maybe we could have some uh, a bit more opaque, so you can't just look at it and see what it is, but you could have like a mnemonic that encodes the descriptor. It'll probably be a lot more than 24 words, uh, but maybe something that you could memorize still, and or maybe some other kind of binary format that is easy to copy around. So there was an idea that was just kind of kicked around on the mailing list, um, where instead of giving a person a descriptor and say back up this string that to them would actually probably look um, like code, like software code, but to encode it in something like base 64 and say here's your magic string to keep safe, uh,
Yeah.
and underneath it's really just the descriptor.
Yeah, right. Yeah, I like that idea, and I think even just the idea of if it could be reflected into a new mnemonic. So even if it was a 30-word mnemonic, and people just put that on, and like we have new metal seed backups that like whatever this new BIP 39, whatever the new one is going to be, that actually has the seed and the output descriptor all encoded inside of it. Maybe that's another approach that would be kind
Yeah,
of feasible, because that's the other thing. Like when you're thinking about when you are recovering some of these things, it might be the hardware might have failed, or even the whole aspect, it might be years down the line, and maybe the support for USB is not as strong, and it's all USB-C or whatever's coming after that, and it's 10 years down the line, and maybe those things are always difficult. And that's why I guess for some people they feel comfortable with the typical BIP 39, 12 or 24 words, because it's just English words in a metal thing, and that metal thing is not going to go up in a fire or whatever.
yeah, and really, this is not to say that the BIP 39 method is necessarily bad. I mean, it's obviously worked for the past um I don't know, like 9 years, 10 years, uh, but but it doesn't lend itself to future extensions. It doesn't work well when we want to add new things and still have something that indicates like this is supposed to be the old method. Um, and the reason that we have descriptors now is really that we noticed this problem with uh, supporting both non-SegWit and SegWit addresses. So it this only really became a problem when we got SegWit and realized, oh, we have a key, but this key can actually be three different addresses. How do we represent this? How do we store it? How do we have users back it up? And how do we make sure that if they restore their backup, that they are getting the right one of those three possible addresses for each key?
Right, right. And so someone could come back and say, oh, but why don't you just check all three of them? But then that might not be a very scalable or sustainable approach if, let's say, that user has thousands of addresses, and now you've got to go and check all of these different things, or you have to check all the past addresses for this person because, they might have money that they don't know about.
Yeah, and it's that's that's what core did. It would you give it a key and it actually converted it into four different scripts. So you have your three. We have our uh, peta pub key hash address, uh, peta witness key hash address, peta witness key hash wrapped inside of P2SH, and then we have peta pub key. Um, there's no address for peta pub key, but core supports uh, receiving on pay to pub key scripts, even if you can't get addresses for it. And if you import a key into a Bitcoin Core wallet, a non-descriptor wallet, so we call these legacy wallets, then Core will internally, in memory, generate these four different scripts and scan the blockchain for all four of them. It eventually, when you have very large wallets, it starts to have a toll on memory usage and potentially even on disk space.
Gotcha. Yeah. And also, actually, this is probably another question people are thinking: is there a relation between the famed XPubs and output descriptors? Is there a relation to them? Is one contained inside the other? Can you help disentangle that for us?
Yeah, so descriptors have a way to represent keys, and and really, what we're doing right now is we're not actually putting the seed inside the descriptor. We're putting an xpub or an xpriv. So from your BIP39 seed, you generate an extended private key, and from there you can make extended public key. So that's xpub. Extended private key is xpriv, and we take those xpubs or xpriv at the very root that comes out of the seed, and that's what we put inside the descriptor. So in descriptors, you'll frequently see the xpub, and then it'll also be followed by a derivation path, and that derivation path is how we get the rest of the keys.
Back to the show in a moment. Have you thought about backing up your Bitcoin seeds? So in this episode, we're talking about output script descriptors, but you still need to back up your 24 seed words, and CipherGrid is a new product by CipherSafe.io helping you do that. It's the best value in the industry, everything you need for $59. This product has privacy by default, the two plates are facing each other. It's stainless steel hardware, you can lock it with a padlock, and you get a tamper evidence seal. You'll also get an automatic center punch provided, and just like all CipherSafe products, it's made from stainless steel, it's fireproof, rustproof, and waterproof. So just think through, don't just rely on that piece of paper, get a metal product for your Bitcoin seed. So go to CipherSafe.io and use the code Livera to order yours. CoinKite.com are the creators of my favorite Bitcoin hardware wallet, the Cold Card. It's one of the most recommended hardware wallets by Bitcoiners. I think it's the best in the market. You can use this device completely air-gapped. I recently did an episode with NVK talking about using the Cold Card as part of your security setup. You can use it with wallets like Spectre Desktop or Sparrow or Electrum or Blue Wallet. Cold Card offers PSBT natively. It works great as part of a multi-signature quorum, and I really like the feature of the Address Explorer. So when you receive coins, you can make sure that you truly hold or you truly own that address. So that's a feature you can use on your Cold Card. So to get yours, go to coinkite.com and use the code Livera to get a discount. So as long-term Bitcoin hodlers, we've got to think about eliminating single points of failure. Unchained Capital are providing multi-signature vaults and a concierge service to help you set up with that if you're interested in this. So if you are using an exchange or custodian, obviously there's a single point of failure, the company's staff and your login. And even if you've got a hardware wallet, you're still exposed to other single points of failure, your wallet, its backup, and even yourself. So with Unchained, you can set up collaborative custody using a 2 of 3 multi-signature setup where no single key controls your Bitcoin. You can have one of those keys shared with a trusted partner who is on hand to help you with recovery. Unchained have a concierge team who can provide you with personal one-to-one guidance, and they'll ship the hardware wallets to you and get you set up. And once you're set up, there are other products available as well, such as Bitcoin retirement accounts, Bitcoin-backed loans. You can go to unchained-capital.com/concierge and get $50 off with the promo code Livera. Back to the show. Gotcha. Yeah. So
that's the relationship.
Yeah, great. And so just to refresh for listeners, so it's like you generate your seed, and that 12 or 24 words represents that seed. From that seed, you get the X priv, as you said, the master private key, and then from that you create the X pub, the master public key, and then that X pub is then combined inside the script, the output descriptor, which shows you how to find all the coins that you have. And that's like a master public, or it's kind of like a public key that allows you to see all of your coins. And then you need the private keys to spend that, obviously. Is that correct?
Yeah.
Gotcha.
So in core, when we generate descriptors, that we do generate a seed. It's not a BIP39 seed. There's a different.
Yep.
There's too many things that we call seeds. We generate a thing we call a seed, and from there we turn it into a master private key that we put inside the descriptor, so that we can then use that descriptor with private keys and be able to sign transactions. But yeah, many descriptors that you will see coming from a wallet will contain an xpub, and that's perfectly normal, and that's fine. Now, if you see it containing a ypub or a zpub, that's not normal, and that's a bug in the software.
Yeah, actually, while we're there, do you want to just explain, what's an xpub versus a ypub and a zpub?
Yeah, so BIP32 defined a way to serialize these extended keys to be used for key derivation, and the result is what we see as xpub, xpriv. Um, when we got SegWit, wallet software, other wallet software vendors needed a way to because previously they would allow you to export an XPub so you could import it into some other wallet. Uh, but with SegWit, they needed some way to say, here's an XPub, but only use it to generate SegWit addresses. And so they came up with, why don't we export an XPub, but instead of prefixing it with XPub, we prefix it with YPub and ZPub. And these are to say keys you generate with this public key are for P2WPKH or uh, wrapped inside of a P2WPKH wrapped inside of a P2SH. So that's what YPub and ZPub are. They're kind of uh, the trick of changing the version number to represent something new. But this is also not sustainable. Uh, what do we? Z is the end of the alphabet. Do we go to APub next for Taproot? uh,
Yeah.
so with descriptors, we can kind of sidestep this problem, avoid this problem, and just say, you know, we'll still use the XPub because BIP32 defined XPub without giving any meaning to what script to create, and then we can just tack on in front of it the scripts that we want to have.
Got it. So just summarizing then again. So historically, it was just xpub, and that didn't necessarily have a specific meaning. But now, well, what happened then is xpub became also the way of representing a specific that the one addresses, right? And then what happened is a lot of the wallets made this ypub and zpub nomenclature to specify, oh, these are your three addresses, and then for the zpub, that was for your BC1 addresses. Like that was what was done. And then, as you're pointing out, that's not very long term sustainable and scalable because we're going to run out of types, and it's just not going to fit with the new context, right?
And it's also not easy, not as easy to understand. Like I look at YPub and I'm like, uh, shoot, why? Which one is it? Is I know I know it's one of the SegWit ones, but I don't remember. Is it P2SH WPKH or just P2WPKH? Same with ZPub. I never remember which one is which.
Right. Yeah. Whereas it's a generalized approach, right?
Yeah, descriptors is generalized, and it's pretty obvious because we reuse common terminology. So with a descriptor, if you see that it begins with WPKH, that should prompt you to remember this is going to make a P2WPKH address. We're reusing the same terms and acronyms that we've used previously.
Yeah. Yeah. And this was historically could have been an issue for people where, let's say, an exchange didn't support sending to Besh32 addresses. They only would send to a 3 address. And then if you're a user and you're sitting there with your wallet that only gives you BC1 addresses, you're in trouble now. So then it became a bit of a game of Bitcoin people trying to shout at exchanges to say, hey, we want Besh32 address withdrawal, we want native SegWit, give us this SegWit withdrawal. And the exchanges might be dragging their feet on that because they would rather support some altcoin as opposed to supporting the best practice Bitcoin stuff, right?
Yeah, and so with adding new things to the wallet, depending on how the wallet software is organized, it might be rather difficult to support new features. I think famously, Bitcoin Core didn't support SegWit addresses in the wallet until 0.16 or something like that, which is about a year and a half after SegWit itself, the consensus rules, was implemented into Core.
Ironic, eh?
So yeah. So this time, with descriptor wallets, it was much easier because now we can just say we've defined a new descriptor and here's the implementation for it, and we just drop it in this spot that we reserve for adding new things to descriptors. Um, so it was really easy to add Taproot wallet support to Bitcoin Core for the 22.0 release.
Yeah, gotcha. And so, as you were saying, it's bringing it back to that idea that it's going to be more future proofing because now when new features are coming out and new things are rolling out, it's going to be all contained in this more generalized form, and that will apply even in the backups and in all of these other aspects when you need to recover something. Let's say your wallet gets destroyed, if it's a phone or a hardware wallet goes up in a fire, or all these kinds of things, that you can recover that now a bit more easily. So yeah, let's talk a little bit about some of those things that it might help enable. Like, I mean, an example might be Lightning wallets. So as we mentioned earlier, that example with Moon Wallet, maybe multi-sig is going to be a bit more
Yeah. So
on a kind of certain standards.
mhm. So descriptors. Right now we have descriptors for all of the major single key addresses. So there's P2 PKH, P2W PKH, SH WPKH, all of those, and then we have another descriptor multi for multisigs. So it's easy to represent a multisig inside of a descriptor, um, and so you can make multisig wallets. There's still some questions about how to coordinate making a multisig wallet, but once you have it, you can represent it as a descriptor, and everyone can take that descriptor and use it. Uh, for more complex things, we actually have uh, an an extension of descriptors that's called Miniscript. So Miniscript is a generalized way to write complicated Bitcoin scripts. This hasn't been implemented into Core yet. There's an open PR, and there's ongoing work on Miniscript elsewhere. Uh, but Miniscript will allow you to make contracts that say like uh, spend only allow this key after this block height or time, or you know start as a 2 of 3 multi-sig, and then after 6 months turn it into a 1 of 2 multi-sig, or whatever crazy thing that you want. Miniscript allows you to make these complicated contracts, uh, and so one of the tests that was done with Miniscript was to see if Miniscript could recreate the Lightning HTLC script, and it can. And I think it's not. It doesn't make exactly the same script. But it's semantically the same. It has exactly the same meaning, and I don't remember if it was more efficient, uh, but it was definitely pretty close to what the Lightning developers came up by hand. And one of the nice things about Miniscript is if you want to make a script, you don't have to understand script and analyze it for months and months to make sure that there's no possible way to screw it up. Miniscript and the Miniscript developers have already worked out most of those gotchas, and so you can use Miniscript to make a complicated script without having to think too hard about uh, possible corner cases.
Yeah. So Miniscript as a project, and I think it was mostly Andrew Polstra, and I think Sankit, I think, also put in some work onto it, and a few people.
Yeah, so it's mostly being done by Andrew Polstra, Sanket, and then Peter Wall.
Yeah.
So those are the 3 main people who work on Miniscript.
Yeah. And so in the future, when we get this might help people. Let's say they've got a big multi-sig and they've got, their family life savings on it or something like that. And they might have some, more complicated big setup of, 5 keys or 10 keys out there. And then what you could do is sort of allow in this idea, as you were saying, that it might back off or back down. So it might start as whatever 7 of 10, but then over time, after a few years, it might back down into like 5 of 10 required to spend or something like that, to kind of create more complicated scenarios. And obviously it will take time for the market to, for the entrepreneurs and for Bitcoiners out there to figure out what are the best use cases for this and how it might be best used and commercialized, importantly. But those are some of the ideas, right, that of how it might be actually used in practice.
One of the really cool things about Miniscript is that it does its own optimization for size. So I'm fairly certain one of the other tests that was done with Miniscript was to see if it could recreate a bunch of other complicated scripts. And one of the ones that they did was Blockstream's Liquid network. It has a complicated script for the Federation, I believe. And what happened was when they used Miniscript to recreate that script, it actually came out with something that was more efficient than what the Liquid developers could come up with by hand. So Miniscript actually did a better job than than the humans thinking on it for several months.
Well, that's an interesting result, hey. And I wonder if it would then have any other applications, like if people were to use, in some kind of wallet that also combines with, say, Lightning and things.
Yeah. I think well, since Lightning has fixed scripts, it's not quite as useful there. So Lightning uses like fixed script templates, but if Lightning needs to introduce new kinds of scripts, then it would definitely be useful. Miniscript also helps with having multiple different signers involved without all of them knowing exactly what the script is. So one of the neat things about Miniscript is that it can be analyzed so that and like analyze automatically. So if you have a hardware wallet that is signing for some arbitrary script that is generated by Miniscript, then the hardware wallet doesn't need to have known what that script was before. It doesn't need to have known what that script does. It can take the script as it comes in, uh, hopefully from a PSBT, and just analyze it on the spot, understand exactly what it does, and then understand exactly what it needs to do in order to sign for that
Gotcha.
transaction.
Yeah. So maybe that could also be handy in other contexts where maybe you have an always on signing box, uh, and these are distributed around, and that's like one of the keys in a multi sig setup or something like that. Kind of like a CK bunker, cold card bunker kind of idea, but
Mhm.
implemented in a mini script compatible way. Maybe that's another way it could be done as like a security thing to add another layer of protection in some way.
Yeah, and like with like the whole fallback thing, fallback after some number of months, that signer could know that it's going to take the fallback case because like the signer could without having seen the script beforehand, read analyze the script, understand what the conditions are, and then realize the fallback case is going to be taken because the lock time in the transaction is some specific lock time, and understand that and know that okay, sign the fallback part or like sign for the fallback part of the script rather than the some other condition.
Yeah, right. Yeah, and I guess this is all super early, so we're just going to have to see what the entrepreneurs and the Bitcoiners out there come up with. Also, let's talk a little bit about Taproot. So, you mentioned earlier that there is going to be an output descriptor type for Taproot. Is there anything listeners should be thinking about from a Taproot perspective with output descriptors? And also, is there going to be a new address type?
Yeah, so Taproot is a new address type. It uses Besh32M, which is a modification of Besh32 to fix a
The PQ thing, right?
yeah, it's called a length extension attack. Is kind of a problem, I guess. Enough so that Besh32M was made. So Besh32M is incompatible with Besh32, but it will look basically identical. The only way you can tell is if you're really good at analyzing numbers. Um, you have to do the math to tell the difference, basically. So so but with the Taproot output is going to have just the public key in the output. So with SegWit, with P2W PKH, and with non-SegWit P2 PKH, what we had was the hash of the public key that you wanted to use in the output. With Taproot, it's still not just the public key itself, and this is important when you're analyzing Taproot descriptors. It's not the public key itself, but it will still be a public key in the output. There's some crazy math involved, and we take the actual public key that we see in the descriptor and we hash it and combine it with some other stuff in order to get the public key that goes in the Taproot output. So if you do see a Taproot descriptor, I think the most common one you'll see will just be TR and then an XPub. The keys derived from that XPub are not the ones that end up in the actual Taproot output that you would see in the transaction. This is something that wallet software writers need to keep in mind, because if you think that that public key is what ends up in the Taproot output, there will be compatibility issues, and we don't like.
You might lose coins.
Well, you won't lose coins, but if you try to restore it to a different wallet, you might not get the same addresses.
Okay, and so then it'll look to
Yeah,
the user like, "Oh no, I've lost my coins," and like,
yeah.
yeah, then it'll be a nightmare again.
Then it looks scary, like you lost your coins.
Yeah.
and
Okay.
and this thing that the thing that happens is such a little it's really subtle because it's like one line in BIP 341 that you should do this thing to generate the output key, and if you don't read it too closely, you will miss it.
Right.
So
Okay.
so when I was writing the specification for taproot descriptors, like I put there, this must be hashed in this way as specified as BIP 341. Just put that again just to reinforce that it's not just the pub key in the output.
Yeah. Yeah. And music too. Any thoughts there? Any impacts there in terms of how, let's say people start using music too in the future for doing multi-sig, or potentially maybe it's even in a lightning context of use of music too. Will there be any changes or things to think about there from an output descriptor point of view, or not really?
Yeah, so there will be probably descriptors or maybe something in Miniscript that allows for music too. Right now, we have decided that the current multi descriptor will not be like overloaded, so we won't have multi mean different things in different contexts. There will probably be like a musig descriptor that contains the keys that you want to have. But music two specifically is a bit more complicated than just representing it inside a descriptor, because setting up music is interactive and
Yeah.
kind of
Yeah.
involved.
Yeah, so I guess that will be a bit of a hurdle to overcome in terms of when people want to do their hardware wallets, multi-sig setups. But maybe in a Lightning context, it's not as bad because you can deal with the interactivity better because obviously you're connected anyway.
Yeah, so Lightning, I think, will be it'll be a lot easier for Lightning to implement music too, because they can talk to each other over their Lightning protocol. But for a generic like multi-sig setup thing, I mean, I don't think we're even there yet with normal multi-sig, let alone being able to do music too.
Yeah. Any thoughts on multi-sig standards? Do you see anything that you think the ecosystem should be doing to move towards that kind of standard, or you think we've kind of already taken the easy opportunities that are out there?
Um, it's a hard problem. There's been a lot of things that have been proposed, and for each one, I can always think of something wrong. But but at the same time, I also have a hard time with coming up with something myself that solves all of those problems. It's not something I've been looking into too much lately, because there are many other things I'm working on.
Yeah.
So I don't have a lot of. It's hard to budget my time.
Yeah, sure.
One thing that I would like is for someone to write BIP 48, and at least, so this is a problem I've complained about multiple times on Twitter, where a lot of software will reference something called BIP 48 for multisig, and yet BIP 48 itself does not exist, which is bizarre and really annoying. So I would like for someone to write down BIP 48 that at least mentions all the things that everyone does that claims to be BIP 48. So at least there's one place to look at it.
The mystery BIP. Okay, so anything to update us on PSBT wise? So partially signed Bitcoin transactions. As the creator of PSBT, do you have anything you wanted to update us on there?
Yeah, I've proposed several new fields for supporting Taproot. So PSBT currently has fields for BIP32 derivation paths and signatures and scripts, but none of these really work with Taproot, especially because Taproot uses a different format for public keys. Taproot uses a completely different signature algorithm. We decided that instead of reusing the same fields, that we would instead just put new fields in for Taproot specifically. So there's a PR open to the BIPs repo, and I sent out a mailing list post several weeks ago that defines these new fields that we can use for Taproot.
Yeah.
And these new fields they'll also work with the two different versions of PSBT that we have. There's no limitation on which version that they work with.
Yeah. Yeah, so just for listeners who aren't familiar with PSBT, it's like a way of having multi stages in your Bitcoin transaction. And so you might have used it in a context where, let's say, you're using a cold card and you're doing a micro SD card transaction back and forth to the computer, or it might have been used in other contexts, or it's like actually being used in the background without us knowing, right? The wallet is just doing PSBT. And it also might have context or applications in things like, say, Lightning. People are talking about this idea of having a channel open from a hardware wallet and then the channel close going back to the hardware wallet. And so the PSBT might be another way that, well, it is a way that is being used to coordinate some of that aspects of that transaction.
Yeah. The new PSBT fields, I'm starting to implement them into core now, although they definitely won't make it for 22.0. Hopefully after these fields are accepted into the BIPs repo and people start implementing them, you'll be able to hardware wallets hopefully will be able to support Taproot, and then you can use PSBT with a hardware wallet to get your Taproot spends that way too.
Gotcha. Yeah. And so, as people have been talking about how Taproot might have some slight benefits in privacy, we don't want to oversell that aspect. There is some small benefits there. And one of those is that in the Taproot world, if we had lots of people using Taproot single signature spends, and there was also Taproot Lightning happening, then in the case of the collaborative channel open and collaborative channel close of a Lightning transaction, that would look indistinguishable from the Taproot single signature, say hardware wallet or even phone wallet or desktop wallet spends, right?
Yeah. So one of the key innovations with Taproot is the idea that everything can end up looking like a public key. So if you have a case where you have a complex script, but at the very top it's everyone involved agrees, then that whole script is collapsed into just a single public key, and it looks indistinguishable from any single key signature for a Taproot output on the Bitcoin network. So it gives you a privacy benefit there if you're doing scripts or multi-sig or anything involving more than one key in the transaction.
Yeah, but I guess let's also be fair that it'll take time for these benefits to come through. Like, so the things that you and others are working on are at a deep technical level, at the protocol level, and then it takes time for that to actually show up in the applications that we use and in the hardware wallets that we use. But eventually we might reach that point. And I mean, just like when SegWit came out in 2017, it took some time for the wallets and some of the exchanges and businesses in the space to actually support it. And so in the early days, it was obviously a very low percentage of SegWit usage on the network. So potentially at the start, by using Taproot, you are sticking out like a sore thumb, right? But over
Yeah.
time, as more and more people use Taproot, then, and that's maybe more of a medium and longer term thing, where once everyone's in the Taproot world, whether you're single sig, Lightning, or DLCs and some other fancy, crazy things and multi-sig stuff, then you all start to look the same.
Yeah. The other thing is that using these complex scripts is not something that we even see on the network today. Uh, I mean, just multi-sigs too. We rarely see, you don't see that many multi-sigs around. We mostly see single key things. So for this privacy benefit to even have an effect, you need to be doing things other than single key things. And until people start doing that, there isn't that huge of a privacy benefit.
Yeah, right. And that's only from a script or output type perspective as well. Of course, there's still chain analysis and there's still the common input ownership heuristic and all of those aspects that you still have to watch out for as well. But this is just one element on which
Yeah.
people can differentiate or distinguish between different output types and then use that to try to cleverly fingerprint you or figure out what's going on chain. And that's where, the chain surveillance companies of the world might try to take away your privacy, and it's that constant back and forth. But nevertheless, it is an upgrade and it's an improvement, and so hopefully over time it gets updated and happens. I think actually I recall seeing even Nicolas Dorier, the creator of BTC Pay server, was talking about this idea of, should we have single spend or single signature Taproot outputs? And I think Peter responded to him saying, yeah, why wouldn't you do it?
Yeah. I am of the same opinion. Why not have single key Taproot outputs? There's also the fact that more single key Taproot outputs also increases the anonymity set for people who do use complex scripts and multi-sigs with Taproot. So Taproot it also has some fee benefits for at least the spenders, people spending Taproot outputs. There's also a fee reason for you to want to use Taproot.
Yeah, well, and that's good. I mean, arguably, then everyone has an incentive because, like, if you are a user of Bitcoin and you're, because even if you are hodling, eventually you might be spending, or if you pass it on to your children, then they're going to be spending at some point. So there's an incentive there. You could argue that
Yeah.
everyone has an incentive to go to Taproot once everyone's comfortable with it and once the software and the hardware is all compatible with it and able to use it. all of those things. So anything else you wanted to mention around Bitcoin development? Anything we haven't touched on?
No, I think that's it.
Cool. Okay. Well, I guess any tips for listeners out there, or maybe any calls for help? Do you want review help or something out there?
Yeah. So if you are interested in reading about reading the specifying documents, the BIPs repo is where all of these things are being specified. So I've got a PR open for these taproot fields for PSBT, and I'm working on writing BIPs for the descriptors. This is it's a bit strange that we've had descriptors in core for like 3 years now, but there's no BIP. The specification is just a document that sits in the core repo. So I decided to finally write several BIPs describing all of the descriptors. If you're technically inclined, or even just want to read about how these work, you can go check out the BIPs repo for those. If something's not clear about how they work, please do leave a comment, because we want these specs to be clear and easy to implement.
Excellent.
Maybe not easy to implement, but easy to understand, so that they can be implemented correctly.
Yeah, great. I'll leave that in the show notes. So listeners, go to stephanlivera.com/292 and you'll find all the links for Andrew's BIPs as well as his mailing list post there in relation to output descriptors. Andrew, anywhere you would like people to find you online?
You can find me on most social media platforms with the name achow101. That includes Twitter and GitHub, Twitch. I also do a stream every Monday where I work on Bitcoin Core. And recently I have started work on my stream doing these taproot fields in PSBT. So if you want to watch it happen, you can come drop by my stream, I guess. And yeah, you can find me. HL101 online is probably me.
Excellent. All right. Well, Andrew, thanks very much for coming on and helping explain these very complicated topics for us.
Yeah, no problem.
Subscribe to the show and find the show notes at stephanlivera.com/292, and I'll get a transcript up there in a couple of days as well. That's it from me. I'll see you in the Citadels.